When most people see a humanoid robot, they focus on what it can do: walking, talking, recognizing people, and performing tasks autonomously. But have you ever wondered what actually makes all of that possible? Just like a human body, a humanoid robot has its own muscles, skeleton, senses, nervous system, energy source, and even a brain powered by AI. So let's open up the robot and discover what makes these incredible machines come to life, one component at a time. Let's start with the muscles. Humans use muscles to move arms, legs, fingers, and body. Robots don't have biological muscles, so instead they use actuators, motors, and gear systems. These actuators generate movement and control the robot's joints. For example, when the robot raises its arm, bends its knee, or turns its head, actuators are doing the work behind the scenes. The gears help amplify torque and provide precise control. You can think of actuators as the robot's version of muscles. Without them, the robot would simply be a statue. Next comes the skeleton. Just like our bones provide structure and support, a robot needs a strong but lightweight frame. The skeleton holds all components together, including motors, sensors, processors, wiring, and batteries. Most humanoid robots use lightweight materials such as aluminum alloys, titanium, or advanced composite materials. The goal is to keep the robot strong enough to operate while minimizing weight. A well-designed skeleton improves mobility, balance, and energy efficiency. Now let's talk about one of the most fascinating parts, the senses. Humans rely on eyes, ears, touch, and balance to understand the world. Robots do something very similar using sensors. For vision, robots use cameras and computer vision systems. These allow them to identify objects, recognize faces, read text, and navigate environments. For touch and force detection, robots use tactile sensors that help them understand pressure and contact. This is important when handling delicate objects. The IMU or Inertial Measurement Unit acts like the robot's sense of balance. It measures acceleration, orientation, and movement. Together, these sensors help the robot perceive its environment in real time. Without sensors, a robot would essentially be blind and unaware of the world around it. Now let's move to the brain. This is where artificial intelligence comes into the picture. The AI brain processes information from sensors and decides what actions to take. Modern humanoid robots often use machine learning models, computer vision models, large language models, and motion planning algorithms. For example, if a robot sees a box on the floor, the AI brain determines, what is this object? Can I pick it up? How should I move my arm? Where should I place it? This reasoning and decision making capability is what transforms a mission into an intelligent system. The more advanced the AI models become, the smarter the robot becomes. If the brain makes decisions, the nervous system carries those decisions throughout the robot. In humans, nerves transmit signals between the brain and muscles. In robots, controllers and embedded processors perform a similar role. These processors manage motors, sensors, communication, and real-time control systems. They ensure commands from the AI are executed accurately and quickly. For example, when the AI decides to take up a step forward, the nervous system coordinates dozens of joints and actuators simultaneously. This happens in milliseconds. Without this coordination, smooth movement would be impossible. Finally, we need power. Just like humans need food, robots need energy. The energy system consists of batteries and power electronics. The batteries store electrical energy while power management systems distribute it to motors, processors, sensors, and communication devices. One of the biggest challenges in robotics today is balancing performance with battery life. More intelligence and more movement require more energy. That's why companies investing in humanoid robots are heavily focused on battery technology and power efficiency. When we put all these components together, muscles, skeleton, senses, brain, nervous system, and energy, we get a humanoid robot capable of perceiving, reasoning, moving, and interacting with the world. In many ways, a humanoid robot is the engineering attempt to recreate the key capabilities of the human body using technology. And as AI, sensors, processors, and battery technology continue to improve, humanoid robots are becoming increasingly capable and practical for real world applications. Thank you all for watching Satish Tech Talk. See you all in the next video.